Hello, my name is Johan. I live in Marken, a small town in the Netherlands. When there's a thunderstorm, I always look out of my window. I love lightning. There are great sparks in the air. Sometimes lightning strikes the lighthouse. That is spectacular, but also a little scary. The next day, I always check to see if the lighthouse is still standing. Luckily, it has a lightning rod. I can also make sparks with my homemade lightning machine. I rub a cloth on this pipe and hold it next to the pot. When I do this a couple of times, I can use the pot to make a mini lightning flash. This happens because of static electricity. Today, Foolproof is about static electricity. But what is it? What can you do with it? And can I use it to light the lighthouse lamp? Time for the first experiment, but not without my super strong assistant. This is Johan, the strongest man in Marken. I have a balloon and a ring from a thin plastic bag. How can you make the ring levitate? No, not like that. Johan, may I have your sock for a moment? There. If you rub a woolen sock on the balloon gets a static charge. I also rub it on the plastic ring. It will get a static charge as well. Let me try. Yes, if I hold the ring above the balloon, it levitates. A balloon is made up of small particles. Here you see them as blue and yellow balls. There is an even number of blue and yellow. They're in balance. When you rub a balloon with a sock, you wipe away the blue balls. The yellow ones are left behind. And that's how the balloon gets a static charge. The same thing happens when you rub the plastic ring. Now, this one is also charged. Blue and yellow balls are attracted to each other, but the yellow balls repel themselves. That makes the balloon levitate. At least, that's what's supposed to happen. Experiments with static electricity work best when the air is dry. So, not in a damp lighthouse. This boy is doing a great job. He can make the plastic bag dance above the balloon. Cool! Now it's time for a simple experiment that's also quite handy. Imagine you are very clumsy and you knock the pepper shaker over and you knock the salt shaker over. Now it's all mixed up. How can you separate the pepper from the salt? With static electricity. Take a piece of pipe and rub it with the sock. Hold the tube above the mix. The tube attracts all the pepper from the salt. Because of the rubbing, the tube gained a static charge. So, there are many yellow balls on the tube. These yellow particles bounce off of each other, but they attract the blue particles. They are in the pepper and the salt. But because pepper is lighter than salt, the pepper is pulled out first. Bon appetit! They make clever use of this at the bicycle factory. A bicycle is made of metal tubes. They get a coat of paint. A machine gives the bike and the paint a static charge. The small paint drops are attracted to the bicycle. That way, less paint is spilled next to the bike. Experiment 3. You can't see static electricity. Can you make a device that detects static charge? Take an empty jar. Drill a hole in the lid. Bend a spiral at the end of a piece of copper wire. Put it through a lollipop stick and stick it in the hole on the lid. Make a hook on the other end of the wire and put 2 pieces of aluminium foil on it. Now your static charge meter is complete. Let's see if it works. Let's first try the tube without rubbing it. I hold it close to the meter. No, nothing happens. Now rub the tube. Yes, look, the aluminium foil pieces move away from each other. That means the tube has a static charge. Experiment 4. Electricity flows to a lamp when you connect it to a battery. It flows from one side of the battery, through the wire, to the lamp on the other side of the battery. The electricity is flowing. Static electricity does not flow. It stands still. This is a piece of amber. When you rub it, you get static electricity. Look, my meter is going off. The Greek word for amber is electron. Electricity was named after this stone. But can you also light a lamp with static electricity? Yes, you can, but only if you're in the dark. Experiment 5. Take a light bulb and a balloon. Rub the balloon over your hair and make sure that it is completely dark. If you hold the light bulb next to the balloon, you see flashes of light. There are other ways you can make static electricity. Put a few sugar cubes in a blender. Your eyes should be used to the dark. The collision of the sugar cubes creates light. You can also do this with tape. Attach 2 pieces together and pull them apart in the dark. The ripping makes a blue light. Of course, this is not enough to light a lighthouse. Lightning occurs by raindrops rubbing against each other in the air. At the bottom of the cloud, there are many electrically charged particles. These particles are attracted by the blue particles in the Earth. They cannot reach the Earth because particles can't jump through the air just like that. They seek a higher point, like a tree, and all go at the same time. Boom! That is the lightning you see. The lighthouse in Marken is the highest point in the area. Lightning has struck it many times. On the outside of the tower, there are at least 6 lightning rods. They ensure the lightning passes along the tower and doesn't go through it. How can I make my own lightning machine? Get a foam takeaway container, some tape, a pair of scissors, and an aluminium bucket. Cut a corner from the foam container and tape it in the aluminium bucket. Now you have a handle. Rub the container over your hair really well, then place it upside down. Put the aluminium bucket on top. Now touch the bucket. Zap! A spark! You can't see it, but you can hear and feel it. Now lift the bucket and touch it again. Zap! Another one. You keep getting a spark. This tanker is bringing new petrol to the station. They fill it by using a thick tube. The petrol flows quickly through the tube. The flow can also create static electricity, enough for a small spark. Because of this, the whole lot could explode. Therefore, the tanker is connected to the ground. This causes it to lose the electric charge and makes it safe to fill. Experiment 7. If you want to make bigger sparks, you need something in which you can save electrically charged particles. Take a plastic pot with a plastic lid. Glue aluminium foil to the outside of the pot and tape a wire on its side. Prick a nail through the lid and fill the pot with salt water. What you have made is called a Leyden jar. You can save electric charge in it, but you must first get it in there. You can do this with a plastic pipe. If you hold the wire close to the nail, you'll get a nice spark. Leyden jars are used in many electric devices. Only they are much smaller and called capacitors. But they work the same way. They save electric charge and release it later. The lighthouse lamp can be seen 20 kilometers away. My sparks are so small, they don't give off so much light. Shame. But when it's misty, a bell rings. Can we make a bell with static electricity? Johan has made something. It's extremely dangerous. If you turn on an old-fashioned TV, a static charge occurs. We can collect this with aluminium foil. We put the charge in these cans. The paperclip between it starts moving. Yeah, listen, a bell. But it's not really spectacular. Nature does a much better job. Static electricity from lightning is the best.